विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ।
Hello listeners, you're listening to Vigyan Ki Awaaz podcast program on STEM popularization, catalyzed and supported by the Ministry of Science and Technology, Government of India and Media for Community Foundation. Project devised and designed by Dr. R. Sridhar and assisted by Ashish Tiwari. Local coordination and production, Professor Subramanian. Content writing by Priyanshu and post-production by Professor Kaushik P. Kanchan of Garden City University, Bengaluru.
Garden City University, conquer we shall all adversity. Together we stand in unity. Together we strive for prosperity. GCU, emphasis on life. GCU, emphasis on life.
Episode, we delve into the fascinating world of soft matter with Dr. K.S. Krishnamurthy, a veteran physicist and consultant at the Center for Nano and Soft Matter Sciences, formerly the Center for Liquid Crystal Research. With a PhD, an impressive 62 research publications, and decades of expertise, Dr. Krishnamurthy has been a guiding force in understanding the complex behavior of liquid crystals. His work spans everything from anisotropy and birefringence to electro-optics and field-induced instabilities, pushing the boundaries of how we use soft materials in devices like LCDs and sensors.
Well, in my own field, Professor Chandrasekhar was a preeminent professor in the field of liquid crystals. He started the International Liquid Crystal Society, as a matter of fact, and he was the president of the International Liquid Crystal Society. Therefore, he was in the forefront of liquid crystals. In other fields, it may be a different story and other people will tell you about it. But as far as I know, in our field, India has been in the forefront, not in the applied aspect, very unfortunately. And that is true, you see, very strangely and ironically, in Germany and in America, a lot of work has gone on in the field of liquid crystals. But the true beneficiaries of liquid crystals are Chinese, Japanese, Koreans, you see. And there has been a lot of, why is this happening in this fashion? The point is, a lot of money is involved in, for example, establishing an applied, the institution, for example. And that kind of money we are not finding. I was told that to make pure liquid crystalline materials free of ions and so on and so forth, billions of dollars have to be invested. And our research projects really will not be able to give that kind of money to us. And that is the reason why also in America, liquid crystals, panels are not made. Panels are made in, for example, in China today, maximum number. And in India also there was some effort actually, Hinduja Company and so forth, they tried to do in Hyderabad, but it didn't succeed. But you see, you ask a question, chips for example, why chips are made in Taiwan and not in America? Cheap labor. You see, wherever the labor is cheap and overall business improvement is possible, you can recover the money, that is where it prospers. And today you are having lots of problems on that front. For example, the rare earth materials China has blocked today. They are not sending it to America anymore. And America has to perforce start preparing their own rare earth materials in their own country. They have to dig up, they have to mine and do all the industrial processing and so on and so forth. That may happen actually. Otherwise, in an internationally, globally competitive world, wherever it is most economical, that is where the things develop. And that is how in Japan, for example, or in China, for example, you are having all the display panels being made. But the fundamentals which lie behind the operation of those panels and devices, they have all been worked out in advanced countries like America, Germany, France, and so on and so forth. In my own field, a lot of work was done in France. Actually, one Professor Duchesne earned also the Nobel Prize for liquid crystal physics. But then France is not the one which is reaping the benefit of it. The benefit is being reaped by other countries, as a matter of fact. Applied area, India has always been slightly lagging behind. Our main strength has been our basic research. For example, take Raman effect, which is extremely well known. And we didn't create Raman spectrometers and so forth, you see. Until the advent of lasers, for example, Raman effect was not much beneficial at all. And today, everywhere in all labs, especially nanomaterials, without Raman effect, you cannot do any work here. So basic sciences we are very strong, and applied work we need to really. With the CSIR was established for the purposes of applied research, and therefore those institutions are focusing, and they have brought forth many things. For example, road making, on new asphalt, and so on. A lot of research is going on in those areas. Dye chemistry, and the National Chemical Laboratory in Pune, for example, they are doing all that. There is a thrust actually, Make in India program and so on. And if that flourishes and comes up in a big way, things will improve. Working on these new materials, that is, as I told you, ferroelectric pneumatic materials. Not much is known at all in this particular field, how they behave and so forth. And therefore our main purpose is, first of all, to know why certain molecules which we are examining exhibit this phenomenon, and what exactly are the forces which are holding them together. And lot of new things are coming up. If you apply, for example, if you apply a very small, let me give you an example. If you simply take a liquid crystalline material which is ferroelectric and just touch that, the molecules will reorient. That means of the order of, is friction voltage, whatever you get, about 100 millivolts, good enough to produce a phenomenal change in the orientation, and therefore the transmission of light, color change, and so on and so forth. All this needs to be understood. First, our present aim is, first of all, to know why the things are happening in this fashion, and a couple of papers which you have now published indicate what are all the problems, complex problems which lie ahead, which require solution. In this field, the Professor Madhusudana is there of Raman Research Institute, and he is a Bhatnagar Award winner and a very well-known international figure in the field of liquid crystals. And we have a collaboration with University of Leeds in UK, and they supply us the chemicals, for example, and we carry out the experiments and try to interpret our results. And we hope that these results will be useful in a broader understanding of the phenomenon of ferroelectric materials. No, I haven't got any award, and this is just the beginning of the research work in this particular field. Prof. Chandrasekhar has been an inspirational figure, and in my lifetime I had the good fortune of meeting Professor Raman and having a conversation with him also. And so these are also not only, you see, any true scientist for that matter is an inspirational figure actually. Professor Venu Bapu, he is no more now, he was the director of a Solar Research Observatory, and then so many people actually have given us inspiration to go on. Passion for research at any age is extremely important. You see, passion in the sense that if you are engaged in a particular research project, when you go home, that project should not vanish from your mind. All the time, 24 hours a day, you should be thinking about that problem and the solution. Then the mind is a very capable thing, you see. It can often surprise you with the solution, suggesting the solution to you, provided you are thinking about that problem constantly. This passion is lacking in many people, you see. Irrespectively of what prospects is there and what employment opportunities unfold before you and so on and so forth, it is very important to love your work and always try to see the truth of what you are seeing. You see, it's a quest for truth and understanding. That is what is extremely important. Thank you.
You were listening to Vigyan Ki Awaaz, a podcast on STEM popularization, catalyzed and supported by National Council for Science and Technology Communication, Government of India. Tune in for more such episodes to Vigyan Ki Awaaz on this platform and also through Spotify, YouTube and Apple Music platforms.
आइए हम सुने विज्ञान की अनकही कहानियां